Hello friends, welcome to video lecture on kinematics of machinery. In the today's session, we'll learn about the steering gear mechanism. Under this, we'll cover the two types of steering gear mechanism such as Ackerman and Devis steering gears. So let us start. The mechanism which is used for the changing the direction of two or more of the wheel axle so as to move the vehicle in desired path is known as steering gear. So when the vehicle takes a turn towards one side like this one, okay, the front wheels along the stub axles turn on the respective pin joint as shown in this figure. Okay, this actually shown by here dotted lines. Okay, before that just consider here. So what's about this one? This indicate the stub axles. So what's about this one? These are nothing but the, this is nothing but the back axle, this is nothing but the front axle. Okay, so what's about the short axle or stub axle? These are nothing but the extended portion of the main axle. Okay, so as to you can just attach the wheels, okay, rear wheel as well as front wheels. Okay, now the front wheel of the side turns through a greater angle than the wheel of the other side. When the vehicle takes a turn towards the this one left side or towards the right side, here the case of the vehicle when takes a turn towards the left side, okay, in front of you. Okay, so when the vehicle takes a turn like this one, so if you look towards this one and this one, so whatever the angle made by the front wheel, if you just see here the front wheel of the of that side, here is the front wheel, front wheel of that side turns through a greater angle than the wheel of the other side. If you just see this angle and this angle, okay, so this angle is greater than this angle. Okay, so in order to avoid this skidding, the two front wheels must turn about the same instantaneous center I, which lies on the axis of the back wheel. Thus, the condition for the correct steering is that all the four wheels must turn about the same instantaneous center. Now look towards this one, this instantaneous center. So instantaneous center is the center. At that instant, if you just extend the line of action of all the actually this one, this wheel, okay, this wheel is here, this wheel is here. If I extend the line of action of this one, okay, so all these lines are passes through this point. Okay, this is nothing but the instantaneous center at that instant. Okay, now here what's about this small a indicate? Small a is nothing but the wheel track. Okay, so what's about this one? L is nothing but the wheel base, okay, or the distance between the front axle and rear axle. So what's about this W? So W here is nothing but the distance between the pivots of the front axle. Here are the nothing but the pivots. Okay, this distance indicate the W. So what's about the theta and what's about this phi? These are nothing but the angle turned by the stub axles. Okay, towards the inner side and with the outer side. This indicate the outer side wheel, this indicate the inner side wheel. Okay, this is nothing but the original position of that all the four wheels. Okay, what's about this indicate? This is nothing but the chassis on which the front axle is here and the rear axle is here. Okay, when the vehicle takes a turn, okay, then so whatever the angle made by this one, angle made by this inner wheel with the this one front axle is nothing but here theta, here is the phi with us. Okay, now we just see the next part here. If you just see from the geometry, what's about the cos of cot of theta? Cot of theta is nothing but the here adjacent side with us EA divided by what's about this one? This is nothing but the EI. So cot of theta we can get in this way, cot of theta equals to EA divided by EI. Similarly, we can get the cot of phi. Cot of phi is nothing but the adjacent side EP divided by a front side with us this one EI. But if you look towards this one, EB is nothing but the addition of this one EA plus EB. Okay, now just here EA plus this one AB. So what's about this AE? AE is nothing but this one, this distance. And what's about this AB? As per our previous discussion, this indicate the W. Okay, distance between the pivots of the front axle. Okay, now just replace this AB by W and keep this one EI as it is. Okay, now take the difference between both these terms, cot of phi minus cot of theta. Okay, so what do we get here? This term AE plus W divided by EI minus the next term. Okay, so if you look to us here, now just focus here, AE plus W divided by EI minus EA divided by EI. Here EE, this one EA and AE get cancelled. So what's about the remaining one? W divided by EI. Okay, so if you look towards this one W divided by EI, so what's about this EI? EI is nothing but L. Okay, so this EI EI is nothing but the L. Okay, so what do we get here? Cos of phi minus cos of theta equals to W divided by L. Okay, so the above equation is known as fundamental equation of correct steering gear. Okay, the steering gears are the mechanism which satisfy the fundamental equation. Now look to us here. Okay, so the one actually animation here available with us. Okay, so in this way you can just see the steering gear. Okay, so here from the geometry actually that relation is developed. Okay, so cot of phi minus cot of theta equals to W divided by L. Okay, so for that we will consider these two triangles, this one and this one, simple one. Okay, let us move towards the types of steering gears. Okay, so the two types are there. First one is the Devis steering gear and second one is the Ackerman steering gear. Okay, so let us start with the Devis steering gear. Okay, now you just focus here. This type of the gear has only sliding pairs. The fundamental equation of gearing in all the position is satisfied in Devis steering gear. The Devis steering gear mechanism is as shown in figure, in which the two arms, this one AG and BF, are fixed to the stub axles. Here are the stub axles AP and BQ to form the two similar bell crank levers PAG and here F or QBF, pivoted at this A point and B point respectively. This LM, here is the L. Okay, this one LM is the cross link which is constrained to slide parallel to AB. The ends of the cross link LM are pin jointed to two sliders S1 and S2. These sliders are free to slide on the links AG and B. Here is the link AG and BM. Okay, this link or BF respectively. So whatever the relation we have seen in the earlier case, it is the fundamental equation. Okay, so if you just see the fundamental equation, so for this case also we can get the one relation. Now let us see. The gear is in mid position during the straight motion of the vehicle with equal inclination of arms AG and BF with the AB as shown in this figure. Okay, so if you just see in this figure mid position, so mid position here the okay this arm and this arm, let us focus on this one. This one, this is nothing but the mean position. Okay, here this is nothing but the mean position. Okay, at that point this actually wheel is here and this wheel exactly here. Okay, so in this case if you just say in the mid position during the straight motion of the vehicle with equal inclination of the arm A and G, this one AG and FB. If you just see here, the dotted line shows here, okay, this is nothing but the original position of that FB. With the AB means here is the front axle with us, okay, so this indicate the AB. The steering is affected by moving the cross link LM, this cross link LM, to the right or left, to the right or left of the mid position, okay. So here is the mid position, okay, with us here, and if the vehicle takes a turn towards the either left side or towards the right side. Now see here, this L dash M dash, here is the L dash and here is the M dash, shows the position of this LM for turning to the left, turning to the left, okay, as shown in this figure, okay. So what's about the X? This X is nothing but the distance moved by the cross link from the mid position. So here is the actually original position, and this is nothing but the displacement of this one, the link takes place. If you look towards from this side also, then let us imagine that when the vehicle takes a turn, okay, towards this side, okay, already shown here, this actually outer wheel start moves, okay, like this one. At the same time the inner wheel is here, okay, that makes an angle theta, this makes an angle phi, okay. So what's about this indicate? This is nothing but the instantaneous center from which all the this one lines passes, okay. Now from the geometry already I seen this distance is nothing but the small x we are getting, okay, because of the movement of this vehicle towards the left side. Now say what's about the h from this geometry we can just get the one by one information. So what's about this h is nothing but the vertical distance between the this one AB and LM, okay. So what's about this D is nothing but the horizontal distance of the point L, this one point L from A, okay. So just see here horizontal distance with us, this one. Also the horizontal distance between the point this one M and this one B point, okay. So what's about this angle alpha? Angle alpha is nothing but the, if you just see the inclination made by AG, this one inclination made by this AG, AG with the AG or this one BF with the vertical when the vehicle is in mid position, okay. So what's about this theta and this one phi? These are nothing but the angle term by the subaxles, okay. Here we can get the theta, here we can get the phi. So after moving of this one, after taking the turn by that vehicle towards the left side, so what's about this one? Initially we are consider this angle. This angle is nothing but here alpha, the same angle we can get here, okay, alpha. So what's about this angle? This angle is nothing but the alpha minus theta. And what's about from this side? This angle we have assumed means here after displacement of this link, okay, towards this one, or the vehicle takes a turn towards the left side, then here the angle made by this one stub axle with the this link is nothing but the phi. So what's about the here total angle? If look towards this geometry, what's about the total angle? Phi plus alpha, okay. Now if you just see here from the figure we can get the information regarding the tan of alpha minus theta, okay. For that, if I consider this small triangle here, okay, so here is the A point with us, here is the L with us, okay, or L dash with us, okay. Just see here I can get the value for the tan of alpha minus phi. Tan of alpha minus phi can be analyzed in this way. So tan of alpha minus theta, okay, is nothing but here. For that, if you concentrate on this one, this side, what's about this length? For that, if you focus here, the D length with us here, and this is nothing but the X with us, means what's about this distance? D minus X. So D minus X is nothing but the front side of this triangle. And what's about this one? This indicates the height. So D minus X divided by H, we can get the relation for the tan of alpha minus theta, okay. Now We know the formula for tan of alpha minus theta. Just expand this term. Tan of alpha minus tan of theta divided by 1 plus tan of alpha into tan of theta. Okay. Now, what do we get here? D minus x divided by h as it is. Okay. Now, from this geometry, now just look towards this geometry carefully. Here, okay, that picture clear to you more. Okay. So here, in this case, if I consider this triangle BM, and let us focus here on the arrow. Okay. So what's about this one? Alpha with us means what we get here? Tan of alpha is nothing but the front side. Front side with us D, and divided by adjacent side with us H. So what do we get here? Tan of alpha equals to D divided by H. Okay. Now, once we get this term, just substitute the value for this tan of alpha as D divided by H. Okay. Here D divided by H. Okay. And just move to the next step. Okay. D by H minus tan of theta divided by 1 plus D by H into tan of theta equals to D minus X divided by H. This term will remain as it is. Okay. Now just start simplify this one. Multiply by this term here. Okay. And multiply by this term too. Okay. This term, and if you just see the base of this one is H with us, base of this one with us H get cancel. Okay. So remaining term, okay, in front of you, D minus H into tan of theta divided by H plus D into tan of theta, okay, equals to D minus X divided by H. Okay. So simplify. H multiply by this term and this term multiply by this term. Okay. So if I multiply by this H term to inside terms, what do we get here? Or just keep this as it is right now. So H multiply by this bracket, and if you look towards here, what do we get here? Dx, this bracket or this actual term multiply by this one. Okay. Now simplify this one by multiplying this term to inside terms. H into D and H H minus this one. Sorry, H multiply by H is nothing but the H square. Okay. So minus H square into tan of theta equals to multiply by this term to inside term. Okay. So what do we get here? D multiply by H here plus D multiply by D square into tan of theta, then minus X into H. Okay, this term, okay, comes here, and then minus X into D into tan of theta. Okay, in this we can get the relation. So simplify this term for the XH. Okay. So keep that XH towards the one side and take all the terms to the other side and see whether any term get cancelled here. Okay. If you look towards this one, this relation, this one actually available towards the right side as well as towards the left side. So HD gets cancelled. Okay. So what's about this XH? I'll take this XH towards the another side. XH equals to, and take this term towards the this side. Okay. Now if you look towards here, all the terms available with us in terms of tan. So take this tan theta as common. Okay. And what do we get here? Tan of theta equals to XH divided by this term. Okay. Now once you get the tan of theta, our task is very easy. Now just move towards the next one. Next part. Before that, just here, you just simplified this one by taking this actually small triangle. Okay. Now similar case here, do the analysis to get the value for the phi. Okay. So if you look towards this picture, what's about this angle? Here the phi with us, here the alpha with us. So what's about the total angle? Phi plus alpha. So from this one, just get the next thing, tan of alpha plus phi. So tan of alpha plus phi from this geometry. Let us see a picture. Tan of alpha plus phi. If you just focus on this small triangle M dash, imagine that something point available here, M dash. Okay. This one and B. Okay. In this way you can get the one triangle. So front side with us M dash. Okay. This one. So D plus X. Okay. Front side. And what's about this one? This is nothing but the H. So for that, tan of alpha plus phi, what do you get here? D plus X divided by H. Also it can be proved that, so from this one, let us get the direct value. It is not necessary to do the analysis, okay, like this one. So what's about we did the step here, tan of alpha minus theta. Okay. So similar, actually you can just develop the formula for the tan of alpha plus phi. Okay. in that case, what do we get here? Tan of alpha. Here we can get the plus tan of phi instead of this theta. Okay, 1 minus tan of alpha into tan of this one phi. Okay, so actually same step in front of you. After that, okay, simplifying, what do we get here? Direct value for the tan of phi. Okay, so in this you can get the hx divided by d square plus xd plus this one h square. So once we get the value for tan of theta and tan of phi, our task is very easy. So here we know the condition for correct steering gear mechanism. Cot of phi minus cot of theta equals to w divided by L. Okay, so what's about the cot of phi from this relation? What do we get here? The reciprocal of this one. We can get the value for cot of phi. So d square plus xd plus this one h square divided by hx will remains as it is. And what's about this one tan of theta? This term goes in numerator, okay, and this term comes in denominator. Okay, so in this way we can substitute the value for cot of phi and cot of theta. What do we get here? You can get the information like this one: d square plus xd plus h square, the base is common, okay, minus d square plus xd minus h square. Whatever the term get cancelled, just cancel them. Okay, so here in this case d square then h square, this term get cancels. Okay, so what's about the remaining one? Xd plus xd means 2xd divided by hx. This term will remain as it is, w divided by L. Okay, so here if you look towards this relation, x get cancelled. Okay, what do we get here? H in this one, d divided by h equals to w divided by 2L. Now what's about the meaning for this d by h? D by h meaning is here. D by h is nothing but, if you look towards this small triangle, okay, so what's about this one? Tan of alpha. Tan of alpha is nothing but d divided by h. So from this you can write for this one, d by h equals to w divided by 2L. So as the steering gear has a sliding pairs, okay, there will be friction and more wear. Though this gear fulfills the fundamental equation of gearing in all the position, it becomes inaccurate after some time due to easy wearing. Let us discuss about the Ackermann steering gear. In this figure, we just see the diagram shows the Ackermann steering gear, which has only turning pairs. Now if you compare with the earlier case, it consists of sliding pair. Okay, we just see here the sliding pair form because of this one. One actually arm is shown here, another arm is here. Okay, S1 and S2, these are the two sliders that actually mounted here in case of the Devis steering gear mechanism. Okay, in this case only turning pairs are there. If you look towards turning pair, okay, initial diagram is here. Okay, in this case AL with us, then AL will form first pair, next one is here, next one is here, next one is here. Okay, so the turning pairs are AL, LM, then MB, and this one AB. Okay, the two arms AL and MB are in equal length and are connected by the hinge joints. Here is the hinge joints. Okay, with the front axle at point A and at point B respectively. The links AB, this one link AB and LM are unequal length. You just see the length for this one AB and LM is unequal. Okay, if you just see the length for this AL and BM is equal. The gear in the mid position with the equal inclination of the arms AL, equal inclination of this arm AL and MB, equal inclination, just see whatever the angle made by this one and this one is same. Okay, that is alpha. The gear is in mid position with the equal inclination of the arm AL and BM with the AB. During the straight motion of the vehicle, in this position, the LM is parallel as here. LM is parallel to the link AB. Okay, the only three positions in which the Ackermann gear fulfills the fundamental equation of correct gearing. Okay, these positions are nothing but when the vehicle moves along a straight path when the vehicle takes a turn towards left side or towards the right side. Okay. So in all other positions, the fundamental equation of the correct steering is not fulfilled. The above two correct positions are obtained graphically by finding cot of phi minus cot of theta at different positions. If the value of cot of phi minus cot of theta or W divided by L is approximately equals to 0.45, then the correct position is obtained. Hence the values of theta and phi are known for the correct position. Okay. The instantaneous center I in Ackerman gear lies on a line parallel to rear axis approximately 0.3 into L above of the rear axis. Also, the whole mechanism of the Ackerman steering gear is on the back of the front wheels, whereas in the Devis steering gear it is in the front of the front wheel. Let's compare this one with the earlier case. It lies in the front of the front wheel. Okay. Now the value of the angle alpha can be now obtained as the value of theta, this one theta, and phi are known for the correct steering. Now if you refer this figure to determine the value for this alpha, it is assumed that the projection of this LM and L dash M dash on the AB are equal. Okay. This means that the projection of L dash L dash on the AB, if I just take the projection of this one here, okay. So whatever the projection of this one and whatever the projection of this M dash on the AB is equal. Okay. This is our assumption for the smaller angle alpha. Okay. So the projection of L dash on the AB must be equals to projection of this M dash on the AB. This can be proved with the help of this geometry. Okay. For that, if you look towards the projection of L dash, if I take the projection of this one here and projection of this one here, okay, you can get the right angle triangle here like this one. A L, if I suppose give the same name here L, and for this one, this case, if I give the same name here L dash, okay, means you can get this triangle here and another triangle here. Okay. So from this one, our ultimate aim is to get this relation, this one L dash length. Okay. So this can be get with the help of the total length. If I consider here this length, you have to just subtract this length. Okay. So from the geometry, what we can write here, AL dash cos of, what's about this angle with this alpha plus theta. So what's about this angle is nothing but, if you just look towards this one, 90 degree with us, so 90 minus alpha plus theta. Okay. So what here we can get. Okay. So for the adjacent side, we can just write here AL cos of, if I use the cos as trigonometric function, okay, into this triangle, then what do we get here, AL cos of 90 minus, what's about the angle, 90 minus alpha plus theta. Okay. Minus this small distance, let's consider this small distance is nothing but the AL. Okay. So AL cos of 90 minus alpha. Okay. 90 minus alpha. So this angle must be 90 minus alpha. So difference of this one we can get here L dash. Okay. Similar case with this one, whatever the this one M, if I assume here and M dash here. Okay. So what do you get here in this case, you have to just subtract, get the value for the small distance here, and you have to just add from this point up to here. So what do you get here, BM, if I look towards this triangle, B this triangle, okay, small triangle form here. And apart from this one, if I focus on this another angle, okay, triangle, okay, what do we get here? From this side, what do we get here? Bm cos of 90 minus alpha, Bm cos of 90 minus alpha. So this angle with this alpha, so what's about here, this angle 90 minus alpha, okay. From that relation, what do we get here? Bm cos of 90 minus alpha. Similar case with the this side, what do we get here? Bm dash, Bm dash. So what's about this angle? Phi minus alpha. So here in this case, if you just see this al dash, this one bm dash, so what's about this? These are nothing but the same length. If you just see here al and bm, the length for this one is the same. Means if the displacement of this al takes place from this initial position to the next position, al and al dash is the same, bm and bm dash is the same, okay. So we can write this relation like this one: al dash equals to al equals to bm equals to bm dash. Now if you just focus here on this relation we have written here, so from this one all the length get cancelled, okay, and whatever the remaining actually this part with us, just try to simplify that, okay. Cos of 90 minus this term, then cos of, okay. So whatever the actually this one with us, just try to expand the terms so that we can get the in this way. Here we know this one, what's about this one? Cos of 90 minus any angle is nothing but the sine of that angle, okay. Sine of alpha plus theta, in this we can get it, okay. Similar case with this one, cos of 90 minus alpha means sine of alpha. So what's about the next one? Similar case with the next term, cos of 90 minus alpha means sine of alpha. And what's about this sine of phi minus alpha? Just expand this one, sine of phi minus alpha, just write initially as it is. Now expand this term, you know the formula, sine of a plus b, okay. In the same way, just expand this one, sine of alpha into cos of theta plus cos of alpha into sine of theta, minus this term will remain as it is. What's about the next one? Sine of alpha as it is. Then what's about the formula for this one? Sine of phi into cos of alpha minus cos of phi into sine of alpha, okay. Now if you just see this relation in front of you, just try to simplify this, write this term as it is, right, take this term here, okay. Then what's about the next one? What's about the next initially just try to sort out the terms related with the sine of alpha and cos of alpha, okay. Once we sort out that, okay, just take this cos of alpha and sine of alpha as common. So in this case, if you just see here, sine of alpha term we have written here, and here from this side we have taken this term, okay, this term towards the another side, this term if I take towards the another side, automatically the sign of this one it changes, okay. Now if you look towards this one, this term, cos of alpha into sine of phi, and what's about this term? Already we have taken this term towards the left side, okay. So what's about this one? This term we have written here. So in this case, when I send this term towards the another side, so what do we get here? Sine of alpha terms, okay. Just take that sine of alpha common from all the terms. What do we get here? So remaining term with us, cos of theta plus this one cos of here the phi will come, and here for this sine of alpha, the 2 sine of alpha with us, that's why minus 2 will come here. And just in the next bracket, if I take the cos alpha as common, what's about the remaining one? Sine of phi minus sine of theta. In this way you can get it, okay. Now what's about the next one? So once we get the value for the sine of alpha and this one cos of alpha, our task is very easy. Sine of alpha divided by cos of alpha equals to this term divided by this one. So in this case, sine of alpha divided by cos of alpha is nothing but the tan of alpha, okay. Now this term will remain as it is. So as the values of this one, theta, phi, and okay, theta and phi for the correct steering gear are known, hence the value of alpha can be obtained from this equation, okay. So this is nothing but the analysis for the Ackermann steering gear mechanism. If you see this picture, okay, that will clear to you more in the detail, okay. So in this case, whatever the instantaneous center as per this animation, okay, that instantaneous center actually passes through the axis of the back axle, but in actual practice this must be above of the axis of the rear wheel, okay, by this distance 0.3 into L. Now if you just see comparatively with the Devis steering gear mechanism, okay, so in case of Devis steering gear mechanism there are the sliding pairs. In this mechanism turning pairs with us, okay. Apart from this one, whole mechanism of the Ackerman steering gear mechanism is lies at the back side of the front axle. If you just see in case of the Devis steering gear mechanism, full mechanism is lies was the front side of the front axle, okay. Then apart from this one, this mechanism satisfies the fundamental equation at all the position, and this mechanism satisfy the fundamental equation only in the three position. It is at the mid position this way was the extreme left side or towards the extreme right side, okay. So this is the difference between the Ackerman steering gear mechanism and Devis steering gear mechanism. I hope that the concept of the steering gear mechanism clear to you. Thank you.